Hi everyone, this is Justin here at Black Module Studio. This is the first of a tutorial series I'm starting on Unity 3D. Hopefully this tutorial series will help you to learn game development with Unity. For this first tutorial I'm going to go over how to edit the height of the terrain object at runtime via a C# script. I decided on this one as it's a very common question asked in the Unity forums as well as the Unity community answers site. A lot of people have trouble dealing with all aspects of Unity terrain at runtime. I think this is mostly due to how undocumented many features are. So let's get started. First off, go ahead and open up your project and scene. Once there, right-click in the Assets section of the Project tab. Go ahead and select Create and C# script. Alright. Now go ahead and give it a meaningful name, generally something related to its functionality. I'll go ahead and name mine Terrain. Then go ahead and double click it or hit enter so it opens it up in your text editor. Mine open on my other monitor. Okay, so this is Sublime Text 2. I've integrated it with Unity, so all the debugging and everything like that, and it just uses it as my primary text editor for Unity. So maybe I'll do another tutorial eventually on that. So now that it's open, we'll want to go ahead and add a terrain variable which will represent the terrain that we're going to be editing. Just ensure that you make it public so we can go ahead and add it to the or add the terrain in the editor. So it's going to be public. It's of type terrain. We'll go ahead and call it my terrain. For the first tutorial, we'll just edit the terrain once the script loads. We'll still go ahead and put this code in its own function, but we'll just call it from the start function. So we'll go and go down here and create that function. It's not going to return anything, so it's void. Let's go and make sure we give it a just pretty self-explanatory name, so we'll call it edit terrain because that's what it's going to do. It's not going to return anything, so we don't need any parameters in here. For convenience later on, let's go ahead and create a few variables that will represent the size of our terrain. We'll call them, let's see, normally I call them height and width, but since you know, we're editing terrain and we're going to be changing the terrain height, these shouldn't really represent height. They're going to be the I guess length and width. I'll just go and call them X resolution and Z resolution. So let's go and set these equal to my terrain. Oops, my terrain dot terrain data dot height map width, and then similarly the Z will be height map height. Alright, now we need something to hold all the points in our height map. This will be the list of values that we will specifically be editing. We'll go and hold them in a two-dimensional array of floats. Let's just go and call it heights. I think that's simple enough. Alright, now we need to set these equal to my terrain dot terrain data dot get heights, and get heights takes 4 parameters. The first 2 parameters are the beginning x and z coordinates, and then the last 2 parameters are the ending x and z coordinates. So think of it kind of like the bottom left and top right corners of a square. So we'll start from 0, 0 because we want to encompass the whole terrain, so we'll start from 0, 0, the bottom left, and we'll go all the way to x resolution. And then Z resolution, so which is, you know, the width and the height of the terrain. So it's gonna be all of it. Now what we're gonna do is we're gonna just make a double for loop in here. We're gonna go from Z0 all the way up to Z resolution, and then we'll have another for loop inside of that will be the x's. Now inside of here let's just go ahead and mess around with this. We'll use some sine and cosine to mess around and make some bumpy terrain. So Rx cosine will equal mathf dot cosine x, and then we'll create another one that will be sine equals negative mathf dot sine z. And then let's go and set the heights variable of this specific coordinate equal to x cosine minus z sine. And then just so you'll see when we get into the terrain, these bumps are kind of big, so I'm just dividing it by 100. Alright, and that will pretty much adjust the heights, the values in that float array, but that's not quite enough. Now we need to actually set the terrain heights equal to that float array. So my terrain data set heights. This is real similar to the get heights function up above up here that takes 4 parameters, except we only take 3 in here. Like get heights, we take the x and the z for the starting coordinate, but then we just pass in a 2D array of floats. That's because obviously the 2D array of floats is of a certain size, and we know that size, so we tell it where to start, and this function automatically knows to end at the end of the array. So we'll go ahead and pass in heights, and that is it. Now the last thing we need to do is actually call our function, so we'll go ahead and copy this and paste it up in the start function. Now that's done, let's go ahead and open Unity back up. Alright. So you should see the terrain script here that we just made. Now we need to actually make the terrain, so go up here to terrain menu, create terrain. Just a basic default terrain, nothing special here, no textures or anything on it. There's a couple ways we can do this. We can either add component, scripts, terrain. We can, with the terrain selected for all these. So select terrain, go terrain, or sorry, component, scripts, terrain, or my favorite way, select terrain and just drag and drop your script in. Pretty self-explanatory. Right here, that variable my terrain that we made public it public so it would appear out here. If we left it private, it would not be accessible out here. It's just a quick way to serialize it and have it available in the inspector by making it public. Right here it's telling us none because there's no value stored in here yet, but it's telling us right here in parentheses it's the value that needs to be in here needs to be of type terrain. So let's go and drag our terrain right in here, and now we are good to go. So we'll go ahead and hit play, and you'll see this terrain get modified, and there you go. Nice, simple, easy. So a lot simpler than some people realize. Now, obviously, this is pretty ugly, and this isn't doing anything spectacular. It's just making a whole bunch of bumps. This likely would not actually be used in a game, but that's all about. Let's see, in here. This is where you're going to want to change. You're going to want to set heights equal to whatever you want at that specific point. Generally, you're not just going to use trigonometry to just change it around. I mean, it depends on what you're doing, I guess, but generally not every single point in the array. Something this could be useful for is deforming your terrain at runtime. Like if you have an explosion that goes off, you can get that area and create kind of a randomized explosion pattern and deform your terrain. Maybe in your game you want to have the players be able to dig a hole. Now, due to some limitations with Unity's terrain and the fact that it's a 2D plane and not 3D voxels, you can't really dig caves and everything. But you could lower the terrain essentially, which would be the same as going into the terrain, selecting a brush, holding shift, and lowering it down. I'm already at 0, so I won't go any lower than flat, but you know, if we have a height and then we want to lower it, it'd be the same thing as doing that in game. So also, you notice when I hit play, the terrain did not get rid of these bumps. That's because how the terrain object is, it actually stores the data regardless of if we're in play or not. If you make changes, those changes will stick. So let's go ahead and hit terrain, flatten height map, we'll set it to 0, and boom. Alright, and just now as a quick little extra, I'll go ahead and show you something real simple here. This way of editing it is fairly quick and responsive. I am using trigonometry here, so this method will be a little bit slower. But if you were not using trigonometry functions, it wouldn't be quite as slow. And mind you, you normally wouldn't change every single point on your map every frame, but that's what I'm going to do just to show you it is possible. We'll go ahead and create an integer. We'll call it counter. Oops, if I could spell. In the start function, we'll go ahead and there we go, counter plus plus, just to, oop, that's wrong, sorry, getting ahead of myself. Counter equals 0, and go ahead and cut the edit terrain function, put it into update, and we will then do counter plus plus in the update function. So every frame we're going to call this, and we're going to increment counter, but in the cosine and sine functions, we're going to add counter to the x and z. Oops. What am I doing? There we go. And that should be about it. We'll go ahead and go in here. And now you'll see the bumps, but they will actually be moving across the oh, what did I do? Oh, there we go. Semicolon, not a colon. Alright. And they'll actually be moving across. So we're going to play, and there you go. You should see it moving around. It is a little bit slower just because we're manipulating, I believe it's roughly 250,000 points here with trigonometric functions every single frame, so it is choppy. But if you were to, I'm just trying to illustrate that you can actually go ahead and make changes to relatively small areas relatively often and not have a significant performance hit. So now if you try and change every single point in your map, every frame, you know, you are going to see the slowdown that I'm experiencing right now. So yeah, hopefully you guys like this. Go and comment and like it, subscribe if you, and I'll have more of these coming soon. Alright, thanks.